Okay, we are looking at the notes for lesson 10-3, the area of regular polygons. So this could be a five-sided figure, six-sided figure, eight-sided figure, but it needs to be a regular figure, meaning all the sides and all the angles are the same. So if it's a five-sided figure, it is a perfect pentagon or a hexagon, where all the sides and all the angles are the same, regular. Okay, this first picture here near the top, you got an unusual looking hexagon, a six-sided figure inside a circle here. There's a couple of words that need to be highlighted. This first one that is pointing right to the center is basically called the center. This line here in blue from the center to the edge of the circle, you'll notice there's a circle there, but really these hexagons don't need to be in a circle. This blue line right there is called a radius. Now it's strange to be a radius inside a regular hexagon, but you can see if you put the hexagon in a circle that this blue line does hit the edge of the circle, which thus makes it a radius. This next one is going to be the most important new word here. From the center straight down 90 degrees with the hexagon. So straight down from the center 90 degrees with the hexagon, that is going to be called the apothem. Apothem. All right, and that is going to be one of the important words for this work here. All right, so the way we're going to figure out the area of a regular pentagon or hexagon or an eight-sided figure is basically we are going to notice that within these figures, like this picture above, there are six, if it's a hexagon, six of these triangles. And what we'll do is figure out the area of one triangle and basically multiply it by 6, or the area, if it's a pentagon, of one triangle, multiply it by 5, however many triangles there would be. And the area of a triangle formula is, we should all know, 1/2 base times height. Well, that's basically what the area of a regular pentagon formula is going to be. Instead of base and height, they're going to say it's 1/2 p for perimeter times not the traditional height, but they're going to use the word a apothem. So it's the apothem times the perimeter. Again, what is the apothem? Apothem is from dead center straight down 90 degrees. That's the apothem. Perimeter, of course, is going around. This is a hexagon here. So it goes around the hexagon like that. Okay, obviously add them up. This is based on the fact that there are, if it's a hexagon, a six-sided figure, there should be 6 triangles inside this figure. If I just kind of drew lines here, 1, 2, 3, all of these triangles are all the same. They all share the same height, which is the apothem, this red line that's from dead center, dead center, dead center down. And the base is really this. These are all the bases here in blue, and that, of course, is the perimeter. So that is how this formula works. It is based on the fact that there are a bunch of triangles, and triangles are 1/2 base times height. Well, this is going to be 1/2. The base is of all the 6 triangles is the perimeter times the height. The height is the apothem from dead center straight down, from dead center straight down. Okay, now I'm going to go into number 1 here, and I kind of already highlighted this picture a bit. At the right, a portion of a regular octagon has radii and apothem that's drawn. For some reason, they only included the bottom half, so I drew the top half of this octagon. I drew it really bad, but basically, all the sides, all the angles are the same. So what you need to do is figure out angle measurements. Before we even worry about the area of this thing, we might need some angle measurements here. So angle 1 there, which is near the center of that octagon, you got to realize to make a complete circle around any point, it's 360 degrees. Well, angle 1, you just divide by 8, since there are 8 angles here that are all the same. And I highlighted them in green there. So 360 divided by 8 is 45 degrees. Angle 2 and 3, I kind of drew 2 and 3 down here, made a bigger triangle there, but basically this red line from the center straight down is the apothem, and that's this red line right here. This is obviously 90 degrees. This was 45 degrees where angle 1 is in green. Now it's going to be split. 45 is going to get split into here and here. So angle 2 is 45 divided by 2, which is 22.5 degrees. And then angle 3 within this triangle down here is going to be a 180-degree triangle minus 90 minus 22.5 is equal to 90 minus 22.5, 67.5. Now we will start to use these degrees later on. You might see some trigonometry involved later on, but you got to just know how to get angle measurements. All right, for number 2, we are going to try to figure out the area of a regular pentagon. A pentagon, of course, is a 5-sided figure with 11.6 as each side and 8 centimeters is the apothem. I kind of drew the picture here. Here is our new formula, 1/2 apothem times perimeter. Again, that is based on the fact that there are triangles. The apothem is this number 8, and the perimeter is not 11.6, but it's 11.6 times the number of sides. There are 5 of these 11.6. So when I multiply this out, this ends up being 11.6 times 5 is 58. And then when I multiply all of this out, it's 232 centimeters squared is the area of this pentagon, which is made up of 5 triangles, all with this apothem as the height, and then the base would be the perimeter. And finally, number 3 here, the sides of a regular hexagon is 10. Find the area of this hexagon. So of course the formula is this new one, 1/2 apothem times perimeter. We've got a side length of 10, so the perimeter is going to be no problem. 10 times 6, that's 60. What we don't know is this apothem number. So we're going to need to figure out what this apothem number is. What we're going to need is some measurements here. This particular side right here, on both left and right, this would be 1/2 of 10, 5 and 5. And obviously all around the hexagon is 10. But we need some angle measurements to help figure out this red apothem. We need to know what these green angles are here. There's 6 of them, so I would go 360 divided by 6. Those are 60 degrees each. So 60 degrees, 60 degrees, 60 degrees, and even that 60 now gets split into a 30, 30. Now I'm going to pull out one of these triangles here, just to enlarge it here. This angle here is 30 degrees. This is 90. This is a 5-inch line there. We need to figure out this A for apothem. Now this here would be 60 degrees. If you know your 30, 60, 90s, this apothem would be 5 radical 3. If you're not sure about that, you can just go stand at 60 degrees and go tangent is 60 degrees is equal to opposite apothem over adjacent 5. And I'm just going to use the calculator real quick. Tangent of 60 multiplied by 5. So this apothem here is 8.66. So that line is 8.66. Now we go back to the equation. The area of the whole thing is the apothem 8.66 times the area, which was 10 times 6. The perimeter is 60. And so when I multiply all of this out, it should be the area is equal to 259.8. I don't know, my point's not showing up there. And this is in inches squared. And that should be it. Point there.